All right, hello everyone and welcome. I'm really excited to welcome Nate Ebel to Chicago Roboto this year. I've had the pleasure of working with Nate for quite some time, and I'm excited to hear what he has to share about GitHub Actions. As with all the talks, don't forget that there is a Slack channel, day1_Nate-Ebel. There you can see on the bottom of the screen where you can post your questions. And otherwise, we will be watching a video from Nate. He's around to answer your questions. And if you have any other questions, we'll get to them after the video, where he'll be able to answer them live. And with that, here is the talk.
Hey, everybody. Thank you. We're going ahead and get started with the talk now. Welcome to building an Android CI pipeline with GitHub Actions. My name is Nate Ebel, and I build Android apps and have a lot of fun sharing things I learn with all of you fine people. Now, I am super excited to be here with Chicago Roboto again this year. I am missing out on that delicious deep dish pizza and all the other fun stuff there is to do in Chicago, but I'm really glad that we're getting a chance to do this virtually, and am just really impressed with how this event has come together. And so I hope we can all have a great time. I would definitely be around virtually in Slack and social media and stuff. So if you'd like to chat, feel free to reach out to me. Hey, do you like samples? Do you like code that you can copy and paste into your project? Well, if you do, check out this repo. The vast majority of samples from this talk today can all be found in my GitHub Automation Sandbox repository on GitHub. Additionally, there's even a few extra workflows in there that you can integrate for your own projects. All right, now back to the talk. Now, GitHub Actions makes Android CI easy. That's what I'm hoping to demonstrate to you in this session here today. Hopefully it will show that with GitHub Actions, we can build a multifunctional CI pipeline for Android without a ton of extra code and with some very easy to understand workflows. And hopefully throughout this talk, we will demystify the CI process a little bit and help you see that GitHub Actions is a great choice for jumping into the world of CI for Android. Now, CI, what exactly is CI? Well, CI stands for continuous integration, which is really just a process of regularly checking in, building, and validating your code. I like to think of it as consistently building the right thing at the right time. We want to avoid situations where something builds and works correctly on your local development machine, but maybe doesn't build and work correctly for another developer on your team. Continuous integration lets us automate the validation and distribution of our code. So we always know that things are testing and working properly, that the code is formatted correctly, maybe that dependencies are up to date. And we always know that it's going to be consistently distributed to our QA team or to beta testers. And finally, we want to save our team time, energy, and hopefully a lot of headaches by automating away the things that are difficult and cause us stress and consternation during our day-to-day work. Now, continuous integration ultimately is running on some server out there on the interwebs. And so GitHub Actions is really one provider. It's one sort of system that lets you build a continuous integration pipeline. And there's other providers out there as well. CircleCI, Bitrise, Jenkins, Travis, CodeMagic. We have a lot of options out there to choose from. However, as the title suggests, we will be focusing on GitHub Actions today. Now, I do want to just call this out, though, that these concepts are certainly transferable. This talk will be focused on specific details around GitHub Actions, but if you're unfamiliar with CI, this talk is still going to be useful to you. It's still going to help you understand how to think about your build, and it'll still demonstrate, some different tips and tricks for the types of things you might want to automate in your build pipeline. So even if you're not using GitHub Actions currently, hopefully this talk will still give you a few nuggets of inspiration to take back into your own projects. All right. So let's go ahead and jump into GitHub Actions, and let's start seeing how we actually build for GitHub Actions. So first off, I want to just define some vocabulary here. I want to make sure that we are all speaking the same language as we go through this talk. So first off, what is a build? Well, I like to think of a build as a set of repeatable, automated tasks run on a remote server out there. And now, what specifically is GitHub Actions? GitHub Actions are really self-contained commands that package specific reusable functionality for your build. They're kind of a convenient way of encapsulating something that might otherwise live in a script somewhere. I like to think of them also as kind of like Legos. They're things we can connect together to customize the different behaviors we want out of our build pipeline. Now, a workflow within the context of GitHub Actions is a triggerable set of build commands, and different workflows can be used for different build types. And we're going to look at examples of several different types of builds as we move forward in the talk. Now, a job is a set of build steps run on the same virtual machine. And finally, a step is really this smallest atomic unit of this build process. And it's really a single task. It could be a GitHub action, a command line task. And that's going to actually perform some piece of work for you. So that could be a gradle task. That could be simply echoing some text out to the console. So all of these things together are really the building blocks of a CI pipeline with GitHub Actions. And so to start, we would make sure that we create a workflow. So in this example, we'll have a workflow called build pull request. Now, in a workflow, we can define a job. Or we might actually define multiple jobs. Now, within a single job, we're going to define the individual steps that perform the actions that we want to carry out in our build process. And each of these steps might be controlled by an individual GitHub action or our own custom command that we choose to execute during that build step. Once you've integrated a GitHub Actions workflow into your repository, you can find those workflows and each individual run in the Actions tab of your repository. So you can click Actions, and here on the left-hand side, you'll see all of the workflows enabled for your repository. And then on the right-hand side, you'll see this list of all the individual runs for those workflows. So if you want to look at runs for a specific workflow, you can click on that workflow. You can find the latest workflows. If you click into that, you can then look at the output for each individual job and then start digging into the output for individual steps within that run. And if you have any artifacts, you'll find those on the main page for that workflow. And you can then click those artifacts and download them and use them on your local machine. All right. So now that we have an idea of kind of what these building blocks are, a little bit of an idea of how to put them together, and we know what it's going to look like within GitHub, let's jump in and start building our own CI pipeline with GitHub Actions for Android. So first off, we need to define our workflow. So we're going to define a workflow within the .github/workflows directory of our project. Now, it's very important. Workflows specifically live within .github/workflows. Now, workflows are defined using a YAML file. So in this case, we'll define a file called build pull request.yml. And the first thing we're going to add to this file is this text right here, just name : build pull request. This will be the name of the workflow that we find within GitHub Actions. Next up, we're going to define when this workflow should be run. In this case, we say on push. Push is a trigger that will run this workflow anytime we push code to our repository. Now, maybe on push is a little bit too frequent. Maybe we don't want to build that often. So we could change it to on pull request. So now this workflow will run in response to pull requests or pushes to an open pull request. Now we need to define the job and start thinking about what this is actually going to do. So in this case, we add the jobs section. We've named our job test job, and then the label, the publicly facing name in GitHub will be assemble. Now this is also the name of the status check if you wanted to enforce that this job passes before you can merge a pull request. And then we have the runs on there. This is defining the virtual machine that this job is going to run on. And so we're going to be using Ubuntu latest for most of these jobs. And that virtual machine has the majority of the Android build tools that you would likely use. It has the NDK, it has different versions of the SDK installed. So it really has taken care of a lot of that setup for you that you might otherwise have to do manually with other providers. Now, once we have added our job, we can start adding steps to it. So first off, we can use the checkout action to check out the code for whatever the reference is for this build. So if this is being triggered against your default branch, it'll check out the default branch. If this is a commit on some other branch, it's going to check out that commit. And it always, by default, checks out the latest commit for that ref. Once we've checked out the code, we're going to go ahead and run the assemble gradle task. So we'll call /gradle w and pass in the assemble debug task. Now, once we have those two steps in place, all we really need to do is push this to GitHub. And once we push it to GitHub, we're going to see that workflow trigger anytime we push code to an open pull request. Now, let's think about expanding our build. Simply running the assemble debug task is not overly interesting, so let's keep adding to this. So we could think about caching. We want to make sure our builds are performant. And if we have configured our application to properly use the local Gradle cache, we're going to want to make sure that we're caching those Gradle outputs in between builds. So we can take use of the cache action, and we can set up our Gradle cache and cache the Gradle/caches directory and the Gradle wrapper. And in this case, we will reference any .gradle files as the cache key. So if we modify our Gradle files, it's going to update the cache for us. So this will let us take advantage of that local Gradle cache and hopefully speed up our builds. Now, once our build is complete, we might want to send a notification to Slack. I think most of the build pipelines I've worked with have all had some type of Slack notification here. So there's a lot of actions out there that let you communicate with Slack. So this is one example of how you might go about doing that. So in this case, we're actually making use of two actions. The first one is this workflow conclusion action. This is useful for workflows that maybe have multiple jobs and you want to get the overall status of that workflow. Let's see why this is relevant in a couple steps here. And then the last step here is this action-slack v3. And this is going to let us really control the message that we're sending over to Slack. It lets us control, where that message is going, the icon, the username that's displayed. But most interestingly here, we have this env section towards the bottom. And we've defined a GitHub token and a Slack webhook URL. These are both using secrets, and secrets are the default place to go if you want to store anything like an API key. So you find secrets in the settings for your repository, and you can add the name of the secret, and then you're kind of a free form field to control what that is. So you might want to store, like I said, your API keys, maybe your app IDs, web hooks, anything that you wouldn't want to just be kind of plain text in your repository. The secrets is the ideal place to do that in GitHub Actions. Now, once we have this Slack notification set up, we're going to see messages that look something like this. And actually, if you want to, you can go to the GitHub-Actions-demo channel in the Chicago Roboto Slack community. I have set up this integration there. You can kind of just check out what those notifications look like. Click on links to specific job runs. You can see all of the many sort of ugly commits I did putting together all of these demos. But it'll give you a feel for what this actually looks like in practice. So once we have our notification sending to Slack, we might want to actually add additional tasks to this. So beyond just assembling the debug variant of our app, maybe we want to add some testing. And then we maybe want to run kt-lint for some Kotlin formatting checks. And finally, maybe we want to run the Android lint task for us. So after we've added our additional steps, now we might want to store the outputs of those steps as artifacts for this workflow so that we can come back and view them later. So here's just 2 examples of that. So in the first example, we've named the step upload test reports. And this is going to take the build/report/test directory and upload it as an artifact to the workflow named test reports. And then in the second step there, upload APK, we are going to create an artifact called APK, and it's going to store the debug APK at that artifact. Now, we've built a workflow now here it's testing, it's running kt-lint, it's doing Android lint, it's assembling. But this might start to slow down your build if you're doing all these things kind of one after the other. So one way to potentially improve the performance of your build is by parallelizing jobs. So instead of having a separate step and a single job, we could actually create a job specifically for these different types of work. So in this case, we've added a job called test job. And this is going to do a lot of the similar stuff we saw from our previous workflow. We're going to check out the code, restore the cache, but then we're going to run our tests and then upload the test reports for those unit tests. Similarly, we could set up a job for running the Android lint tasks. And again, the same setup in this job, but then we're just running a different linting command and then uploading those linting reports. And finally, same thing for the assemble task. So in doing it this way, we can now parallelize this work. Each of these is going to run at the same time, so it cuts down on the amount of real-world wait time for your team. Now, if we're doing this kind of all at the same time, we probably want to wait to send our Slack notification till the overall workflow finishes, maybe not just right after the assemble task. So we'll actually create another job, this time called notify build status. And this job does something interesting here. You'll see towards the top it says needs, and then we're passing in a list of names of other jobs in this workflow. What this is going to do is say that this job will not run until each of these other 3 jobs has finished. So this lets us avoid sending off any notifications until the workflow is actually completed. Once you've enabled multiple jobs for all of the different work we want to do for our build, we can find all of those within the GitHub UI here. And we'll see over on the left-hand side, by splitting this out into multiple jobs, it makes it very clear to see the status of each individual one of those jobs. And here in the Artifacts tab, we see clearly that we have test reports, linting reports, kt-lint reports, and an APK. So it's very easy at this high level to see kind of the overall state of the job. And if we then want to go and look at how individual jobs were run and what the output was, we can go in and look at the individual steps for any of those unique jobs. Now there's one issue with this setup with having the Slack notification depend on the other jobs. The issue here is that if one of those other jobs fails, then this job will never run. So one way to get around this is to update each of those individual jobs and to add continue on error equals true. And so what this will do is say that if that job fails, do not automatically cancel all of the other jobs, which is the default behavior. And so in doing this, our tests can fail. We can still upload the test reports. The status check for that job will still fail, but the dependent job for the Slack notification will still run, and the workflow as a whole will still succeed. So as long as you are preventing or checking the statuses of individual jobs, you don't actually really lose anything here. You can still prevent merging code if things like your test job fails. Now, there are some trade-offs here to think about if you're going to do multiple jobs versus a single job. So one is build times. I mean, you do want to think about whether having multiple jobs is worth it or not. If all of your build steps are quite fast, then there's probably no need to duplicate the setup and parallelize the work. There's also a pretty close correlation between build times and cost for running GitHub Actions for your project. So even if your real world build time is maybe only 10 minutes, if you have 3 jobs all taking 10 minutes, that's actually 30 minutes of billable build time. So you have to be mindful to take that into account when calculating the cost for your team. Now, another interesting aspect to this is how do you want to measure your builds? If you are having all of your build steps in maybe a single invocation of the Gradle wrapper, it's really easy to measure all of that as a single build if you're using something like build scan in the Gradle Enterprise, for example. If you're breaking it up into multiple jobs, it might be a little bit harder to measure the overall build time because you'd have to aggregate the build time for all of the different tasks and individual steps within your job. So there are some complexities around this for how you want to measure the performance of your build. And then just kind of in general, multiple jobs does add some complexity to your build because you are in different virtual machines. So it makes passing artifacts between jobs much more challenging. If you have steps that require the artifact from a step before it, you probably need to keep that within the same job. So you have to be aware of what types of dependencies, inputs, and outputs you have in between the different steps within your workflows. Alrighty. So we just covered a lot about how to get up and running with our Android build. You know, we're running tests, we're running linting, we have our artifacts being uploaded, we're sending Slack notifications. Let's add some more. Let's go through and add a nightly build to our CI pipeline. And if you're not familiar, a nightly build is generally thought of as a build that's going to run automatically on a schedule, usually in the evening when there's not as many people active on your team. This is a great way for, let's say, your QA team to collect all of the changes that were checked in during the day and test it all in a single APK. So to create our nightly build, we're going to start off by once again creating another workflow file. So again, we'll create this at .github/workflows, and we're going to call this one buildnightly.yml. And we'll give this one the name of nightly build. Now we need to define when it runs. So this time we'll say on schedule, and we will define a cron schedule here using kind of standard cron syntax. So in this case, this should run at a 12 midnight UTC standard time. So what do we want to do in this nightly build? Now, we probably want to do a lot of the same stuff we just did in our regular pull request build. So I'm not going to cover that stuff again. However, nightly builds are also a great opportunity to add long-running tasks, stuff that you don't want to wait for in your day-to-day work, but you do want to check and automate. UI tests are a great example of that, in my opinion. So if we want to add a job for Android UI tests, we can start by adding the new job in our YAML file. We'll call it Android test. And this time, when we define the runner, we're actually going to define the Mac OS runner. This is very important because of how the virtualization needs of the emulator are taken into account. On the Linux runners, we don't have the virtualization that's needed to really make the emulator performant. And if the emulator isn't really performing well, your tests just kind of fail with kind of weird cryptic errors. So if you want to be running your Android UI tests using GitHub Actions, you probably want to use the Mac VM. And because the Mac VM is more expensive, you'll want to be mindful about how much work you're doing in that job and how long that's taking so that you don't needlessly run up your bill for GitHub Actions. So once we've set up our job, checked out our code, we can take advantage of this Android emulator runner action, which makes setting up the emulator and installing the code to it and running the tests all very simple. So with these couple lines of configuration here, we can run our connected debug Android test command and validate our UI tests. And once those tests are run, we can upload those test artifacts. And now we can go and view the output of that workflow and see whether we had failures, see what the results of our test suite look like. Now there's one other quick little thing I just want to throw in here. A nice touch to have when setting up your build pipeline, especially for open source project or a project that has a lot of visibility maybe within your company. It's nice to have a build status. So if you want to add a workflow status badge to your README, we can update that so that it looks something like this. You'll see we already have two badges added, one for an Android CI workflow and another one for a workflow called Do Something That Needs Scheduled. So now let's go and add a status badge for our nightly build workflow. So we'll go to the Actions tab, scroll down to the workflow section on the left, and we'll find nightly build. We'll click on that. And then in this little overflow menu here in the upper right, we'll click on that and select Create Status Badge. Now from within this, we can choose which branch we want to create the status badge for. So we're going to use the default branch for our nightly build since that's what it's being run on. And then we'll just go ahead and copy this text here. And we can click the button to copy it for us. So we click that. We'll see the little copied message there. Now we can go to our homepage again. We can then just open up our README directly from within GitHub. Go ahead and select Edit. Then I'm going to just do a new line here, paste in that URL. I'm going to preview the changes, and we see that we now have our nightly build badge added. So I'll come down here to the bottom, update my commit message to say add nightly build badge, and I'll go ahead and commit this directly into my main branch. Now that I've done that, if I come back down and view my README, we'll see that we have our newly added nightly build badge. Okay, so we're building our pull requests. Now we have our nightly build up and running. Let's think about how we might customize builds based on specific branches. So we're going to walk through an exercise here of how we might think about setting up a build for, let's say, a feature branch. This is something that my current team has. And for us, feature branches are a great place to sort of collect larger tasks that are maybe going to take 1 or 2 sprints and let our QA team test those in isolation. So for us, we have a couple concerns here. We want to be able to set this build up based on specific branch naming conventions. And then we want to be able to distribute builds from these branches to Firebase app distribution so it's easy for our QA team to get access to them. So we're going to walk through how we might do that with GitHub Actions. So again, we'll start by creating a new workflow. This one will be called buildFeatureBranch.yml. We'll give it our name of buildFeatureBranch. And this time, we're going to make this run on push, but only on pushes to branches that have the naming convention of feature / and then something else. So this will limit this workflow to a convention of having feature branches start with the word feature. Now, another thing that's important to our team is that our feature branch builds are easy to identify. And so you might think about different ways of setting up your version name and version code. And one common practice is connecting your version code to the build number of your CI system in some ways, because those are generally unique and auto incrementing. And so you automate away some of the challenges associated with trying to keep your version codes unique. So we'll just walk through a real quick example of one way that you might do this. There's actually a lot of actions out there that can help handle semantic versioning for you. But so this is just a real quick, easy way to go about a small piece of this. So imagine we have a Gradle file called app versioning. And in that, we've basically just defined this quick little method that will try to get an environment variable called version code. And if that variable exists, it'll use that as the build's version code. And if not, it'll just default to this default version code we have. So now within our workflow, we can get access to the individual workflow run ID by referencing github.runid. This is one of the sort of default standard set of environment variables available for your run. And then we can set environment variables to just this single task. So in this case, instead of setting the environment variable on the job as a whole, we limit it to just this task. And now when our app is built, that environment variable is available for that Gradle function we wrote. And so now that we've built our app, we want to distribute it to our testers. And like I mentioned, my team, we use Firebase app distribution. So if we wanted to distribute this to Firebase, we have an action for that, which is a common theme if you start digging into GitHub Actions. So we have this action called Firebase distribution GitHub action, and it's actually quite simple for us. We have to first, assemble our APK, and then in this action, we point it to that assembled APK. We can define which testers or which test groups we want it to be distributed to. In this case, I have a group called QA. And then we have to define two secrets. We have to pass in the Firebase app ID so it knows which Firebase project to send it to. And then we need a Firebase token. And in the case of this project, I set the Firebase token up using the Firebase CLI and then stored that resulting token using GitHub secrets. So you could do this without an action using the Firebase distribution plugin directly in your project. But I kind of like this approach because you don't have to actually modify the code of your project in at all. You build your APK as you normally would, and then you let this action do this distribution for you. And this results in, the Firebase console looking something like this. And so the version name there is 1.0. And then I'm appending that run ID to the end of that. And so here we can see the individual run IDs from the workflow that ran them. And so now we know that we're going to have a unique ID for each of these builds as we distribute them, and makes it easier to communicate and share with our test team, and also makes it so that we know we're not going to run into issues if we try to upload it to Google Play. All right. So we are building our pull requests. We've got our nightly build. We're sending builds off to our QA team. Now it's time to start thinking about how we're actually going to release our project. And I think in the release project, there's so many ways that you might release. And so I'm going to walk through just one small example of what a release process might look like. This is not prescriptive. There's so many things to take into account. So you'd really want to think about how to customize your process to fit your flow. But we'll look at a couple interesting steps that are probably applicable to most release flows that we might want. So again, create a release workflow here called buildrelease.yml. We're going to name it build release. And this time we're going to look at a new trigger. So GitHub Actions can really be run in response to just about anything you can do within GitHub. And one example of this is that we can have a workflow that runs in response to creating a release in GitHub. So in this case, what we're doing here is saying anytime a release is published this workflow will run. So once that is triggered, we will go ahead and set up our assemble job, and we're going to run our assemble release task to assemble our release APK. Now, if we are thinking about releasing this, we need to make sure that we sign this. And again, there's lots of ways that we can go about signing our applications. However, if you just want to get something up and running very quickly, there is an action for that called sign Android release. And so we can add that action here in a step called sign release. And then you point it to your APK and you give it the necessary key store information, and that will automatically sign your release APK for you. Once your APK is signed, we can think about uploading this and attaching that as a binary to the release that was just created in GitHub. And so to do that, we're using this action here called GitHub Action Publish Binaries, and it will take the file that you specify in the args parameter there, upload that as a binary to the latest released publish in your repository. Now, once we have attached that binary to the release, we want to actually go ahead and upload this APK to Google Play so we can start running it through the release process. So again, we have an action for that called upload Google Play. And again, we need to specify some information to help it know what app we are. So you'd have to create a service account and point the service account JSON to this action. You define the package name of your application, and then you can configure how you want it to be distributed. So you can specify which track. So in this case, we specified internal. You can also specify sort of release notes using this what's new directory, which is a convention that this action provides. But basically you define some text files that can be localized within your repo, and it will grab those text files and use those as the what's new information or for the release notes in the Google Play Store. And then lastly there, you can also upload your mapping file so that you can, map your obfuscated stack traces properly. So we just took a look at a lot of different useful actions, a lot of different ways we could think about building out our CI pipeline and building different types of things within our Android development process. However, GitHub Actions really goes far beyond just the world of Android. So I want to take a step back and just chat through a couple of the different types of actions that are available for us. So there's an action out there that will help you interact with first-time contributors to your repository. If they create an issue or a pull request or interact with your repo in some other way, you can specify some type of message, greet them, thank them, do whatever you want. Nice little touch to make your open source project a little bit more friendly or make your internal repos more friendly to new hires. Another action that I quite like is for setting up Danger. Danger is a tool to sort of automate the attachment of messages to PRs. So you can run, let's say a code style check and then comment on your PR where the code styling issues are, for example. Or you can, leave messages to help people remember to add descriptions to your PR. So you can just do a lot of interesting things. This action makes setting that up super simple. And like I mentioned before, there's actions out there to manage semantic versioning for you, generating new version codes, all that. Something that plays nicely with that, there's also actions out there to auto commit changes to your code. So if you do need to make some type of systemic automated task and you're making that change all the time, you can automatically commit that back to the project, saving you a little bit of dev time. There's an action out there for comparing APK sizes, which is something I know I've wanted to do in the past. And then, code coverage, another example there. There's actions out there that support different ways of reporting on code coverage statistics in your project. And really, there's hundreds, probably thousands of actions out there for doing lots of different things, analyzing your code, uploading artifacts, interacting with the GitHub system. Lots of different things that you could think about doing. We all have these nice reusable actions at our disposal. So this is all great in theory. All this sounds good in a sample project. It's nice to point at a talk. But I do want to give a few examples of real world experience with this. Some of the thoughts that I and teammates have had as we have worked with GitHub Actions in our real production applications. So here is a small list of benefits or improvements that we found in using GitHub Actions. So first off, faster builds. My current team, we are prototyping using GitHub Actions for our build over Travis, and we have seen something along the lines of a 10% build speed reduction in just pure Gradle task execution. But then we're seeing something around like a 60% overall build time improvement because we are having to install less things on the GitHub runner than we have to do on the Travis runner. The virtual machine starts up almost instantly, whereas our Travis virtual machine sometimes takes 5 or 6 minutes to actually start the build. So we're just seeing a much better overall dev experience so far in GitHub Actions. Another benefit that people on my team have commented on is they feel GitHub Actions reduces complexity. They don't have to know as much about the individual scripts that are being run. The actions just is easier to comprehend because it abstracts away a lot of that behavior for you. So it's more approachable for everyone on your team, which I think is a good thing. It lets more people understand what the build is doing. Another thing that we quite like on our project is that by splitting out work into clearly defined and clearly named steps, or even more so, if you split work out into individual jobs, those are surfaced really nicely in the GitHub UI. And particularly with jobs, it's also then very easy to check those job statuses in your pull requests. So if tests fail or linting fails, it's very easy to surface that into your PR and know exactly why your build failed. Increased automation. I think this is another sort of secondary effect that I've seen is that because we have all this automated behavior, it gets people in the mindset of thinking, how can I automate stuff and what other things can we automate? And then there's all the functionality there to actually do the automation. So it really is helpful in starting to automate your workflows and not just strictly build workflows, but other things you might be doing. And then lastly, great documentation. I have found working with GitHub Actions to be very easy. There's good samples for a lot of the core stuff. And then the third-party sort of marketplace for working with Actions is quite rich. And those tend to be pretty well documented. And so it's very easy to go and find something that you need, pull it in your project, and start playing with it. So where to go next? You've sat through the talk. You think GitHub Actions sounds great. What are some next steps for you? Well, there's 2 great GitHub resources here. So the first off is the marketplace where the individual actions are listed. You can find that at github.com/marketplace and then search or filter for actions. Secondly, the documentation is quite good. Like I said, I've linked to that documentation on this slide here. Secondly, I have kind of an intro to GitHub Actions for Android tutorial on my YouTube channel. So you can find that at the URLs on this slide as well. That'll kind of help walk you through kind of the basic PR example that we looked at the beginning of this talk. So final thoughts here. Start small, pick a couple actions, put those into a workflow, and then expand as needed. Don't set out to build this huge multifaceted CI pipeline all at once. Build only what you need. And as you go, think about ways to improve your system as you find those pain points. And that is really it. Thank you so much for watching. Like I said, I will be around virtually in the Slack community, on social media, always generally available. If you have questions about GitHub Actions, you want to just chat. If you have interesting workflows that you'd like to share, I'd love to chat with you. I'd love to just say hi. So feel free to say hello. And I hope that you all have a great rest of the conference. Thanks for watching.
All right. Thanks so much to Nate Ebel for that really insightful talk. We have one question in the Slack channel that we'll get to. If you have any other questions, make sure you get them into the Slack channel, and we'll try to cover them here. So moving on right into that, Nate. Victoria asks if you have any experience sharing workflows across multiple repositories.
Yeah, it's a great question. That's something that I haven't done anything overly sophisticated with this. My experience with this so far has been copy what's working from one project into another one, and then customize it for the needs of the new project. As the conversation in the Slack channel kind of pointed out, though, there's probably a more interesting way of doing this, in which you might try and encapsulate the common parts of a workflow into a single action, and then maybe make that configurable for whatever parts need to change, like maybe the specific build tasks or something. But you could actually create your own custom action and share that with your team, and basically reduce your workflow from maybe 50 lines or something down to 5, just enough to import that action. So that's something I haven't tried, but with talking with you, Ryan, and Victoria, I think that would be really interesting to try. So if anyone has experience with that, I'd love to chat with them.
Excellent. Thank you so much. And let's see, we've got one more question. Do you have any experience uploading a bundle to something like internal app sharing track, or sending shareable links to a Slack channel that you can share?
Yeah, definitely. So in the full version of the talk, which I recorded because I forgot that I was only doing a 20-minute one, so I did a 40-minute. In the second part of that, I do walk through some examples of that. So walk through one example. There's an action out there for uploading an APK to Firebase app distribution. So I walk through a workflow of that, and the sample code for that is in the GitHub repository. There's also, we walk through kind of a release workflow that enables you to share your APK to Google Play. And with that, you can control the track. So you can control, internal test, beta, whatever. So you can control some of those. And I think, I can't remember if it's the action in the example or if there's a separate action, but I have seen a way of very easily uploading to like the internal app sharing and getting the shareable URL. And then once you have that, you could add that as an output of the job, or add that as just an environment variable and share that down to a next task and share that with Slack if you wanted. So those types of workflows are definitely supported, and probably with just a few lines of configuration.
Excellent. Well, thank you so much. Again, we've got, there's a few more questions in the Slack channel that I'm sure Nate will get to. We have just about 2 minutes until Vishnu comes on for our next talk. So I'll leave that here. And again, thanks so much, Nate.
Yeah, thank you. Have a good conference, everybody.